My dear student, physics class for class 9, chapter 5. The name of the chapter is State of Matter and Pressure. In my today's class, I'm going to discuss about Pascal's law. At first, I'm going to write down the statement of Pascal's law, and then I'm going to give some mathematical analysis on the basis of this Pascal's law. Suppose, at first the statement, Pascal's law. If pressure is applied in a closed container inside some liquid, then that pressure does not diminish. And acting perpendicularly in each side of the container. Each side of the container. Okay, my dear student. So this is the statement of Pascal's law. According to Pascal, it is said that if pressure is applied in a closed container having some liquid inside it, then that pressure does not diminish. That pressure does not less down. Okay, it's acting equally and acting perpendicularly in each side of the container. What does it mean? If you have some liquid in a closed container, just like a cylindrical piston-based container, you're going to apply pressure into the container. Then it's said to me that that pressure does not diminish. What does it mean? That pressure does not decreasing by any kind of effect, and it's acting equally and also perpendicularly in each side of the container. I repeat, my dear student, it's acting equally and perpendicularly in each side of the container. It states to you that applied pressure will equal to the obtained pressure will equal to the experienced pressure inside a liquid, inside a closed container having some liquid. On the basis of this concept, on the basis of this law, a very special kind of instrument is designed, a machine is designed that is called hydraulic press. My dear student, that is called what? That is called hydraulic press. Now, my dear student, hydraulic press. Hydraulic press. Okay, my dear student, hydraulic press is this kind of instrument. This shape of instrument is known as hydraulic press. It has a mouth. This is a mouth, small piston. It is a mouth. This is a large mouth. Okay, my dear student, it has two mouths. One is small mouth, small opening. Another is large mouth. It's a large opening. Okay, and then a piston here, my dear student. This is a piston here, just like a cover in which you can apply pressure in one side. Okay, this can apply pressure in one side, and this piston having no leakage in it, so there's no chance of liquid just comes out from the piston, just comes out from this given piston. Okay, there's no chance of it. And here this is a large piston, and this also large piston having a closed piston, large part having a closed piston. Okay, this also having a piston, so I can say that this is small piston and this is a large piston. And this is a large piston, okay? This is a large piston. Now, my student, I'm going to apply a downward force in small piston. So, in this small piston, I'm going to apply a downward force. In a small piston, my student, I'm going to apply here a downward force. And again, my student, in this large piston, a force is acting in it. Suppose input pressure is P1. I repeat, my student, suppose input pressure or applied pressure is P1. And then the obtained pressure or output pressure is here P2. And this container, suppose having some liquid inside it. Okay. The basic contribution of the piston is here. There's no chance of liquid comes out from the piston. Suppose when you are going to apply pressure in the small piston, or when you're going to apply pressure in the large piston, then you see that in the case of small piston and also in the case of large piston, there's no chance of water to comes out from this piston. I repeat, from this piston. So piston just ensure here one way of movement. So its movement, it can move only in this direction to in this direction. Okay. In this particular one-way movement of liquid is ensured by the piston. Okay. It's just like the valve by the student. It's just like the valve. You know that in the vein, there are so many valves there. So in the vein, there's so many valves there. Okay. So the basic work done, basic function of the valve, that valve can ensure the one-way movement of blood. I repeat, inside the valve, inside the vein, the valve can ensure the one-way movement of blood. Okay, the one-way movement of blood is ensured by this valve. Now, my dear student, according to this Pascal's law, we can say that the applied pressure will be equal to the experienced pressure. That is, applied pressure is P1, and now the experienced pressure is here P2. So we can say that pressure P1 will be equal to P2. So this is the basic mathematical formula for the case of Pascal's law. I repeat, this is the basic mathematical formula for the case of Pascal's law. So here P1 will be equal to P2. Now, my dear students, you know that pressure P will be equal to force per unit area. Okay. Suppose here applied force is F1 and area is A1. So this is F1 and A1. And again, my dear student, in the case of large piston, suppose experienced force is F2 and area is A2. Experienced force is F2 and area is A2. Okay. So here force is F2 and area is here A2. Now I'm going to just establish that. I'm going to reset that force is at one side, force can stay at one side, and the area of cross section can stay another side. Okay, and because of this, I'm just going to interchange here this F1 and this A2. My student, interchange here this F1 and this A2. And if you make this interchange here, then you can say that this is A2 by this is A1 will equal to, it will equal to F2 by here, my student, F1. Now change the side, then you can say that F2 by F1 will equal to what? Will equal to here A2 by A1. Okay, my student. So this is the mathematical equation for the case of Pascal's law. I repeat, my dear student, this is the mathematical equation for the case of Pascal's law. Okay. So this is the applicable equation. This is the mathematical equation in the case of Pascal's law. Here F1 is the applied force. F2 is the obtained force. A1 is the area of cross section for the case of large piston. A2 is the area of cross section for the case of large piston. So A1 for small piston, A2 for large piston. Any question, my dear student? Any one of you? Any question here, my dear student? From any one of you? Any question here? My dear student? Any question? From any one of you, my dear student? Okay. Now, my student, you see that? Yes. Have any question, my student? Yes. Have any question, my student? Okay. Now, we know that the
No.
basic. Yes. Very good. We know that the basic formula for area of cross section A will equal to what? Will equal to pi into r square. So what is r? R is the radius of cross section. R equal to radius of piston at, so just this is enough, radius of piston. Okay, so here r equal to what? Radius of piston. So if you convert this formula in terms of radius, then you can say that f2 by f1 will equal to what? A2 will equal to pi into r2 square, and then a1 will equal to pi into r1 square. You see that, my dear student, here pi cancel out from both sides. Okay, from numerator and denominator. So here f2 by f1 will equal to, this is r2 square divided by here r1 square. This is r2 square divided by here r1 square. Okay, so this is the formula for the case of Pascal's law or hydraulic press. So these are the two formula when you apply Pascal's law. One is f2 by f1 equal to a2 by a1, my dear student, and here another is f2 by f1 equal to r2 square divided by r1 square. I repeat, my dear student, r2 square divided by r1 square. Okay, so these are the two formula to apply Pascal's law. Any confusion, my dear student? Any confusion here up to this line, up to the mathematical formula of Pascal's law? Any confusion, my dear student? Okay. Now I'm going to solve a creative question on the basis of this hydraulic press or Pascal's law. My dear student, I'm going to solve a creative question on the basis of this Pascal's law or hydraulic press. Okay. I'm going to solve a creative question. So let's see this creative question, my dear student. So let's see this creative question. Okay. On Pascal's law. Suppose, my student, this is a hydraulic press. This is the small piston, and here this is the large piston, having some liquid inside it, my dear student. An upward force is here. Now F1 and here F2. Area of cross section is A1. Area of cross section is here A2. Here A1 equal to 0.25 meters square, and then here A2 equal to 3 meters square, my dear student. Here A2 equal to 3 meters square, and then you see that here F1, suppose 10 Newton forces applied. Suppose 10 Newton forces applied, my dear student, in the case of small piston. Now question number C. Calculate the value of F2, my dear student. Calculate the value of F2. Okay. So this is a mathematical question. Question number C. That is, calculate the value of F2. This is the question number C, my dear student. Calculate the value of F2. Now, question number D. According to the given hydraulic press, draw a graph of F2 versus F1, for different value of F2, my dear student, for different value of F1. So this is the question. So my dear student, you see that there is a hydraulic press is given as a stem. In the small piston, applied force is 10 Newton. Area of cross section is 0.25 meters square. My dear student, area of cross section is 0.25 meters square. In the large piston, the experienced force is F2 and it is area of cross section, and that area is A2 will be equal to 3 meters square. That area is A2 will be equal to 3 meters square. Okay, this area at the case of large piston. Question number C, calculate the value of F2. You are going to find out the value of F2. And question number D, according to the given hydraulic press, draw a graph of F2 versus F1. My dear student, F2 versus F1 for different value of F1. Okay, my dear student, now we are going to solve this question. Question number C. You see that all of the information is given in the stem except F2. So I'm going to apply here Pascal's law. So when you are going to apply here Pascal's law, then you can say that F2 versus F1 will equal to A2 divided by this A1. A2 divided by this, my dear student, A1. So from this equation, you are going to find out the value of F2. You are going to find out the value of F2. And it will equal to here A2 divided by A1 multiplied by F1. A2 divided by A1, this is multiplied by F1, my dear student. Now A2. A2 equal to what, my dear student? A2 equal to what? A2 equal to 3 meters square. A1 equal to 0.25 meters square. F1 equal to 10 Newton. Now find out the value of F2 in terms of Newton, my dear student. Now find out the value of F2 in terms of Newton. Okay. Now find out this. My student, now find out, calculate this equation and find out the value of F2. F2 equal to
120 Newton.
Is 120 Newton. Okay, very good. It is 120 Newton. My dear student, all of you, is it completed to calculate this a value of F2? My dear student, all of you, is it completed to you to calculate the value of F2? It is 120 Newton. My dear student, is it completed? My dear student, is it completed to calculate the value of F2? It is 120 Newton. Or any confusion? Any one of you? And confusion here, my dear student?
No, sir.
Okay, very good. Now, my dear student, question number D. According to the given hydraulic press, draw a graph of F2 versus F1. I'm going to draw a graph that represents F2 with respect to F1 for different value of F1, my dear student, for different value of F1. Okay, so I'm going to draw this graph. You know that to draw a graph, at least you should require 2 points for the case of straight line, and at least we should require 3 points for the case of a curved path. We don't know what should be the shape of the graph. It may be straight line, or it may be the curve, or it may be the just like a cycle. So that's why to justify this, I'm going to take here 3 points. I'm going to consider here 3 points. You know that for the case of graph, the first important point is here the origin point, the starting point. So what should be the starting point of the graph? When no force is applied and the small piston, I think this is the starting point of the graph. I repeat, my student, I think this is the starting point of the graph. In this particular case, you can say that no force is applied on the small piston. Now, question number D. My student, if no force is applied in the small piston, then let's see what will be the value of the graph. Okay, suppose for F1 will equal to 0 Newton. Then you see that F2, if you want to find out the value of F2 from Pascal's law, my student, then what should be the equation of F2 for Pascal's law? F2 is equal to A2 divided by A1 multiplied by F1. So F2 equal to what? F2 equal to here A2 divided by A1, and this is multiplied by F1. Okay, this multiplied by F1. So this should be the equation. Now, if F1 equal to 0, then I think F2 is also 0. Multiplied by 0 will equal to what? 0 Newton. My student, will equal to 0 Newton. So you can say that if F2 equal to 0, then if F1 equal to 0, then F2 equal to also 0. I repeat, my dear student, if F1 equal to 0, then F2 equal to, it is also 0. Then F2 equal to, it is also 0. Okay. And then for F1 equal to, my dear student, for F1 equal to 5 Newton, then F2 will equal to what? F2 will equal to here A2 divided by A1 multiplied by F1. So A2 equal to 3, A1 equal to 0.25, okay, and multiplied by F1, and F1 equal to 5 Newton. Now find out, my student, the value of F2 in this particular case. My student, now find out the value in this particular case. Okay, so in this particular case, what should be the value of F2? My student, F2 equal to what? What is the value of F2?
60 Newton.
It is 60 Newton. It is 60 Newton is the value of F2. My student, 60 Newton is the value of F2. Okay, clear? And again, my student, for F1 equal to 10 Newton. We already find out this in question number C. Then F2 equal to, it is 120 Newton. So these are my 3 set of data. When F1 equal to 0, F2 equal to 0. When F1 equal to 5 Newton, F2 equal to 60 Newton. And when F1 equal to 10 Newton, then you see that F2 equal to 120 Newton. My student. Then you see that F2 equal to 120 Newton. Okay. So these are the 3 set of data in my hand. And now, by using this 3 set of data, I'm going to draw the graph, that is F2 versus F1. Now let's draw the graph. To draw the graph, I'm going to erase answer number C. Okay, my student, I'm going to erase here answer number C to draw the graph. You see here, this is the graph. Okay, and this axis is the value of F1, and this axis represents the value of F2. F1 in terms of Newton and also F2 in terms of Newton. And this is the origin point, my dear students. This is the origin point. Origin point. Indicate what? F1 equal to 0, F2 equal to 0. Now, this is 5, this is 10, and this is 15. So 5, 10, 15. Now, you see that for the case of value of F2, this is 0, 16, 120. So I'm just consider here just like this. This is 16 and this is 120. Okay. So no need to draw this here. 15. Now sketch this just like a graph. Okay. Sketch this just like a graph, my dear student. Sketch this just like graph. Okay, you see that when F1 equal to 0, then F2 equal to also 0. So this is the first point, my dear student. And then you see that when F1 equal to 5 Newton, then F2 equal to 60 Newton. So this is the second point. And then when F1 equal to 10 Newton, then F2 equal to 120 Newton. So F1 equal to 10 Newton, F2 equal to 120 Newton. Okay. So this is the third point, my dear student. So this is the third point. Now I'm going to draw a straight line. I repeat, my dear student, I'm going to draw a straight line. Okay, you see that these 3 points represent a straight line, my dear student. You see that these 3 points represent a straight line. Okay. So since these 3 points represent a straight line, so this is the shape of the graph. The graph is look like a straight line, and look like a straight line, and this straight line passing through the origin. So this point is point A, my dear student. This point is point A, and you see that this graph is look like a straight line, and that straight line passing through the origin or passes through the origin. Okay, my dear student, this straight line here passes through the origin. Okay, my dear student, any confusion, any one of you about this creative question? Any one of you, my dear student, any confusion here about this creative question? Yes.
No, sir. আপনি স্যার ফার্স্টে স্যার স্যার F1 ইকুয়াল টু স্যার 0 নিউটন কে স্যার কেন ধরলেন, এরপর স্যার 5 নিউটন ধরলেন, মানে স্যার অন্য কিছু স্যার ধরলেন না কেন?
Okay, very good question, my dear student. You see that in question number C, it is said to be that for the case of value of 5 Newton, 10 Newton, I'm going to find out the value of F2, okay, in answer number C. So it gives me an idea that F1 equal to 10 Newton, the data is given to me, that is known to me. Okay, now my first question to draw the graph is you must mention the starting point of the graph. Now, my dear student, what should be the mention point but starting point of the graph? You see that when F1 equal to 0, then F2 equal to 0. So that's why I'm just consider here F1 equal to 0 Newton. And this point gives me the idea in which point or from which point this graph starts its journey. I repeat, my dear student, from which point this graph starts its journey. Okay. So this graph starts a journey from origin point. Now, my dear student, another data is known to me, that is for 10 Newton force, F2 equal to 120 Newton. So first data is known to me and next data is known to me. So in this particular case, I'm just consider 5 Newton because to know the shape of the graph, I repeat, by the student, to know the shape of the graph. Okay, you may take 2 Newton, you may consider 3 Newton, you may consider 4 Newton, you may consider 5 Newton, no problem, whatever you may consider. But I'm just take a point so that there is an intermediate point in between 10 Newton and 0 Newton. Okay, and that should be the 5 Newton. So that's why I'm just consider 5 Newton as the intermediate point in between 0 Newton and 10 Newton. Okay, my dear student?
Yes, sir. Clear.
Any more confusion, my dear student? Any one of you? Any more
No, sir.
confusion? Any one of you?
No, sir.
Okay. Okay, my dear student.